What I'm going to ask you to do is to set up a project. Now, a project is a thing in RStudio that stores all of your stuff in one place. And what we like about projects is that you can switch between projects quite easily and you go right into kind of where you were in those analyses. So for someone like me, where I'm moving between different research projects all the time, I can set up a project for this paper and then a different project for this paper. And then I can draw on, like easily switch between them as I need to, which is the role of an academic all the time. So to set up a project, what we do, this is an RStudio thing. We will go to File and New Project. All right, and you can set up a new directory or you can use an existing directory if you want. And what we want to have is some folder somewhere on your computer, wherever you want to have it. For me, I've got like a folder that I use for all my projects. And then within that, like all my research projects, and then within that, I have R folders. And this is going to store things like my data, my analysis scripts, and my output is all going to be, for me, in the one folder. That's how I prefer to do it. So what I'd like you to do is set up a folder like that for today. All right. So you can either do a new directory where it's going to set up a directory for you, or if you've already made a directory for yourself somewhere, you can choose existing directory. Either one is fine. So I'm going to choose existing directory here, and I'm going to browse to find the one that I'm after. Now I have this workshop folder set up. This is an existing directory, so I'm going to use this one and create a project. All right. Now, this is now a thing called an R project file. And I'll show you what that looks like. Here we go. So there's this file here called .rproj. And this is a thing for RStudio. And this saves all of this setup. So this is actually me sort of mucking around with some code before this to make sure it all works. And just by clicking on this project, I can easily go right back into it. If I want to switch to another project that I've been working on, let's do this one, for example. I just go up here and I can select a different project and I switch right over to another folder with different files, different data, different code, all of that sort of thing in there. So projects are, an RStudio thing, not an R thing necessarily, and they're fantastic. So I'll go back to the one that I've got set up over here. And at the moment, yours will look blank. You probably you'll only have like one project in here, like an R project. You probably just have the R console here. You might not see this yet. This is a script, and we'll talk about this in a moment. And you'll probably have nothing up here in your environment as well. So I'm showing you what we're going to build towards, which is having a script with analysis code in here, having an environment up here, which is all sorts of things like loaded data sets, analyses, those kind of things. And down here is my folder at the moment with my files in it. And I have some data files and things here, which I'm going to use in a sec. So any questions so far, just getting a feel for what's where and where we're heading with this. Is it okay? All right. So let me start with a new blank project. So it looks like what yours do, so that you get a bit of a sense of where we're going with this. All right, so I'm going to call this new 2. You can call it whatever you want. You probably want to give it better names. So things like, maybe start with a date, the paper name that you're working on, whatever makes it easy for you to easily remember when you see in this drop-down menu here, which one is the one that you want. Okay, so is this very much what yours look like at the moment? Yep. Great. So we've got R here, and I can type stuff into R if I want to, but what I would prefer to do is to start making like a bit of a script here that contains all of the things that I want to do, like loading data and changing data and calling on analyses and things like that. So this is what we call a script file, and these things are awesome. Now, towards the end of this, we're going to build a script file first, and towards the end of this, the aim is to have you showing you some best practice of how I tend to do scripts. Now, because I do it, of course, it's best practice. But you might find other ways of doing things. That said, the way that I do it, a lot of other people do it this way too. Okay, so what we're going to do is we're just going to start with a new script. So we'll call it file, new file in RScript here. Notice there's a whole bunch of other types of files in here you can do. I'm not going to play around with many of these other ones today, but I am going to maybe show you some of the things like RShiny apps, which are fantastic. Things like R Markdown and stuff. We might play around with that a little bit next week. Okay, so file, new file, and script. For those of us who are used to SPSS, this is the equivalent of syntax. So this is where you type out all your commands and everything. All right. Now, at the moment, what I might do is I will stop sharing and I will reshare just the R window, hopefully to make it a bit, RStudio window, hopefully make it a bit bigger for you. Is that a bit easier to see? Hopefully it's bigger on your screen. Okay, so at the moment, we've got this R script up here and it's called Untitled1. And you see R's moved down the bottom here. So up here is my script. This is my console. This is my environment and history over here. And this bit over here is like my files. And later on, we might have some plots. This is also where you can find help and stuff like that too. Okay, so we want to start doing some things with some commands. And I'm not going to focus today, at least not straight away, on opening our own data. I sort of want to move to that a little bit. I'll do it a bit later if we have time. I want to start off with some existing data. So R actually has all these built-in data sets that we can use. And to see what they are, we can type data, open and close brackets. R is case sensitive. So you need to make sure that you don't have like a capital D there or anything like that. And it's open and close brackets here. All right. And when you've got that typed in, you'll see Untitled1 up here has become red and it's got a little asterisk next to it, which indicates that you've made some changes and nothing's saved yet. So before we do anything else, let's save our script as well. And so we'll go to File and Save. We'll save this as a script. You can call it whatever you would like to call it. Let's call it like, basics or introductory or Fred, call it whatever you want. It's fine, just as long as you know what it is. You'll see in my best practices later, I start putting numbers at the start of my scripts, the names. And the reason for this is because I have a sequence that I work through. And then I know which one comes first and which one comes second. But I'll show you that later. Let's just start with one called basics. Okie dokie. So this is now saved as basics, and I've got this stuff here that I want to run. Now, what you can do is you can go down into the console and you could type it down here directly into R. And if you want to do that and hit enter, it will do what you asked for. It will show you a list of the data sets. Okay, so these are all the built-in data sets, but I don't want to have to keep typing stuff down into my console. So this is the real advantage of using the script thing. What I can do is I can select the bit of script that I want and I can hit run. And that'll do it for me too. And this is usually the better way to do it. All right, particularly because you're going to see we're going to start running sequences of commands too. And you don't want to have to type them all into your R console all the time. So this is one of the big things about RStudio is this idea of scripts and being able to develop this script as you go. All right, so I've got all these data sets here and they kind of tell you a bit of what they are. And notice they are like case sensitive. We've got these ones with capital letters, like they're alphabetical. We've got all the capital letters first, and then we've got these ones that start with lowercase letters further down here. You'll see that there's a few of these that are, so I'm flagging that these are here so that you can just play around with them in R and, just try different types of data and see how it works for you without having to load your own data. But you'll see that there's a couple that are really commonly used for showing people how to use R. And these are things like MT cars, which we're going to use today, and also Iris. And for those of you who are in the Jamovi workshop last week, Iris is one that we played with there. So I'm going to talk you through today using MT cars, but I would like you to maybe try and replicate some of the stuff that we're doing, maybe using Iris or one of the other data sets, or play around with it a little bit more if you would like. So, and we might even have some time for you to play around with them today too. All right, so we've got a script set up and we've found a data set that we want to open. So let's actually go and open it. We're going to use a command called data again. And this time in the brackets, we're going to specify that we want to open MT cars, all lowercase MT cars. Okay. And when you got that set up, you can run that. So I'll give you a second to have a go at running it without me reminding you how to do it. Everyone still with me okay? Did everyone get R open and everything? Is everyone all right? It's very quiet in here. Cool. All right, so I'm going to run it. And what you see now is I have this thing over here in my environment. So the environment is stuff that's loaded, ready to play with. All right. So at the moment it says promise next to it, which I assume is another quirky stats thing. I don't know what's going on, but try clicking on it and see what happens. And so you'll see what happens is we've got, this now says 32 obs of 11 variables. So obs, 32 obs is the number of observations, number of cases in our data. Typically for us, this will be people, you know, if you're in psychology or similar research. But in this case, these are different types of cars. So, you know, they're not necessarily called like people or cases or whatever, they're called observations. And we're kind of used to those data sets where there are columns and rows, and columns are variables and rows are people. And that's often what we use in RStudio or NR, but it can deal with a lot of other types of things too. All right, so we've got 32 different cars, and for each car, we've got 11 different variables. Now, these are all, you can move these windows to help. So we've got variables like MPG. These are all car things. So miles per gallon, how many cylinders. I don't know as much as I should about cars. Number of gears, you know, all sorts of types of things there. All right, so we've got all sorts of different variables. And what we like about this data set is it's got a combination of categorical and continuous variables. Some of them have 2 levels, some of them have 3 levels. It's the kind of thing where you can combine variables into meaningful chunks. So it's a useful data set to play around with for demonstration kind of purposes. Now note, when I clicked on MT cars, this sent a command to the console called force MT cars. Okay. Now it hasn't saved that up here in my script. It's just sent it to the console. So if I want this to happen again, then I can actually type it up here and send it. Make sure there's no typos. All right, so I can actually type it up there and send it. So the point being that if you have something like that, it won't always necessarily go into your script, and you might have to add it yourself. You can also, you know, sort of copy and paste out of here too. Okay. All right, so having a look at our data set here, we've got a sense of what all of the different variables look like, which is good to start off with. But, you know, we're not usually, like this helps us get a sense of our variables too. We can see that like VS is zeros and ones, AM is ones and zeros, gears seems to be number of gears, 3, 4, I don't know, cars could have 3 gears. But anyway, you know, we're starting to get a sense of our data here, which is good. There can be better ways of getting a bit of a summary of our data as well. So let's try summary, which is often a really handy command to know. And if we do summary MT cars, we get this thing. which is our 5-number summary, which is minimum, first quartile, median, third quartile, and maximum values, as well as a mean in there too. So this is not a bad start. But what I note from this is I've got some variables in there like VS, for example, which is all zeros and ones. And it's giving me like means and stuff, which doesn't really make sense for categorical variables. So R's a bit smarter than this, surely, isn't it? Let's see how we can fix that. Let's try having a look at another command, which is str, which is structure. And this will help us understand how our variables are coded. Now, one more thing to flag is I'm typing these commands up. I don't have these memorized necessarily. Most people who work in R do many of, like, how often when you do an analysis do you do the same kind of thing each time? You know, you might do a similar regression each time. You don't look up the code every single time you do it or like memorize it and type it all out. Most people have like a code library somewhere, like a document of like, here's how you do a regression. And then they just adjust it for the project as required. So don't feel that like you're seeing me typing this stuff and you're like, oh my God, how am I ever going to remember all of this? You know, the idea is to let, work it out the first time. And actually GPT is pretty good at giving you these commands too. And then, keep records of those. You'll get yourself into a routine of how you do things. And this is why I find like the structure that I've got set up that I'll talk about a little bit later in terms of how I do my analyses will hopefully be helpful. All right, so let's do structure. And so str, mtcars, and you'll see for each of the variables here, it's given me a little thing here which says num, and then the values that are in there. And num means that these are being treated by R as continuous variables. All right. Okay, it's fine. It's a continuous variable. Sure, everything's a continuous variable, but there's a lot of cases here where we'll actually want to make it not a continuous variable. We want to make life a little bit easier. So we're going to do a thing now where we're going to make one of them not a continuous variable, but instead we're going to make it a factor. All right, and in doing so, the factor is a categorical variable. And in doing this, I'm going to show you a few things all at once. So what we're going to do is we've got this variable called dataset called mtcars, and within it, we have a variable called sil. So the format that we use here when we're referring to a variable in a dataset or a data frame is we have our dataset mtcars and then the dollar symbol and then sil, CYL. Okay, and so this is calling on the cylinder, CYL variable within the mtcars dataset. Okay, and what I can do with this is I can actually make it a factor. So we do as factor mtcars $sil. Now don't run that yet, please. Okay, so what this is going to do, this is going to take that cylinder thing and make it into a factor, a categorical variable rather than a numeric variable. But I want to make sure that I actually save this back into my original data set. So what I will do is I will do mtcars $sil and then this arrow. All right. And mtcars $sil, what it's going to do is this is making this thing into that. So we're creating this thing called mtcars $sil. It happens to already exist. And we're going to make it so that it's the factor version of mtcars $sil. So this is going to save that back into the same data set. Now, you could save this as a new variable if you want to as well. You could call it sil underscore factor, for example, or you can just overwrite the original variable. You'll see from my workflow that I'm going to show you later that normally I don't like overriding existing variables, but because of the way that I do it, it's not too bad. Now, this doesn't actually overwrite this variable. Like let's say we've loaded a CSV or an SPSS data file or whatever. It doesn't actually overwrite it in the original data. So I can go back and call the original data again, and it'll be back to like how it always was. This only changes this within the version of the data that we've got loaded in our environment. So if I do something and stuff it up, I can just go back to loading this data set again and fix it, and it's okay. All right, so it's quite handy like that. All right, so run this now when you're ready. And this has created a factor version of cylinder here. It's called sil_factor. I renamed it. You don't have to, it's okay. And now what I'd like you to do is try the structure command again. So structure mtcars. And you'll see I've got a new variable in there called sil_factor. And this is a factor with 3 levels. Okay, so it's 3-group variable. All right, and now let's try that summary again. All right, I can just copy and paste it and run it again. And you'll see that it's not actually giving me for sil factor here, like mean, median, mode, or not mode, mean, median, quartiles, min, max, all that kind of thing. It's not giving me that anymore. It's giving me how many observations, how many cars have 4 cylinders, how many in this list have 6 cylinders, and how many have 8 cylinders. All right, so I've made that summary work a little bit more appropriately for a categorical variable. Now, the point of showing this is there are times when you're going to have to set things up as categorical variables because it's going to make subsequent analyses a lot easier for you. All right, because R does some stuff automatically, which makes life cool. So any questions about any of that so far? You can have spaces in there. I want to say that it's pretty okay with like sort of standard kind of spacing. It can break a little bit if you have like spaces between lines. So let me think of an example. If I were to do something like, I want to try and think of a command that I would do. So I can't think of one off the top of my head, but what you can do is something like this. What is it? Empty cars, $sil, and then a comma, and then break those brackets over to the next line. So empty cars, dollar, what's another one? VS, for example. So this is often a really nice structure. You notice it starts to align those variables with each other too. So it can deal with breaks and things like that. And actually it uses them quite a lot to make the code a lot easier, or like a lot of people do use that to make the code a lot easier. But breaks here, this is sort of expected. You can have breaks within brackets, like, if you wanted to specify some things here. So there are like subcommands you can build in too, which I'm not going to talk too much about today. But that's where spaces would be. So there are places where it does expect spaces. Yes. Cool. Sorry, I'm not sure that was super clear in terms of my answer. All right, so now I've got this cylinder factor set up. All right, and that's looking really good. Now, notice I'm starting to get a bit of code going on here, and I'm running a couple of things twice and everything. So let's start commenting on things in our script to make stuff a bit more easy. Now, in SPSS, for anyone who uses SPSS and uses syntax, you might know that you can do comments by starting a line with an asterisk and make notes to yourself. You can do the same here, and you can do it even better than you can in SPSS. So let me show you what I mean. This data thing up here, I don't want to run this every time I run this script. Okay, so I'm going to make a note to myself going hash. So hash is the thing that we use. Only run this when I need it. All right, and I don't have to finish with a full stop or anything. I've left a note for myself. And what I'm also going to do is add a hash at the start of this one to make it so that it won't run. So when I select the whole script here and run it, it won't give me this set of data sets every time because I don't need to see that. So you can have certain parts of your code that you'll run, that you have in there in case you're sharing your code with somebody else, but you don't need to run each time. So you can comment them out. Now here, I'm going to go, all right, so, hash load data. All right, so I'm loading the data here. All right, so then hash, have a look at the data. Then here, hash set new variable called sil. factor. And then here, like recheck data. Now, I'm not expecting you all to type all of this. I'm trying to show you how you can write notes to yourself to make things a lot easier. All right. Notes in SPSS, when you have a hash, like you have to when you have a star, you have to have the star at the start of the line. What I like with R is you can actually have a hash anywhere along a line and it will ignore everything after that. So, you know, set a new variable rather than overwriting. So here I've got a comment right next to one piece of code that's going to make it so that I can, you know, remember what this exact line is doing, and it will still run this bit of the code. It will just ignore everything from the hash onwards. But as soon as I start the next line, it's ready to run that again. So you see green things, green text here are things that have been commented out so that you can make notes to yourself. And it's a similar idea. There are similar things in SPSS. It just works slightly differently. And particularly this idea of being able to have something at the end of a line is really, really handy. Now, if I've got a whole chunk of things that I want to comment in and out, I can select them. And on a Mac, it's Shift, Command, and C, and that will comment all of those out. So I'm assuming it's something like Shift, Control, C on a Windows machine. You can try it and let me know. Yep, cool. And you can just do it again to take away the hash there as well. So so what I'm trying to get you used to here is setting up your syntax here as a bit of a like chronological thing that you work through and make notes to yourself here to remind you what they all are. One more thing I'll show you is sometimes when I have like big sections in my data, rather than having sometimes my syntax gets ridiculously long. And so it's really hard to find the things you want. So I can, you can make these headings look like whatever you want. So I'll sometimes make them look like this, which really makes it stand out a bit. So now this is recoding data. Okay. All right. That's just a handy little tip. Any comments or thoughts or questions or concerns or what the hell is he talking about questions so far? Have I lost you all? Yes. Yeah. Yeah. So it's good like that. All right. Okay, I'm going to continue. I always find stone cold silence a little bit like, how's this going? But it's all right. Chris is online with me. I appreciate it. All right. Now, the next things I want to show you, because we're going to start using them a little bit now, are things called packages. And this is where we can add on extra functionality. All right. Now, these are great. So if we go over to this side here, and there's a little packages box here, here's a whole bunch of packages. These are like add-ons to R. So you've got this base R here, but there are these things where you can add all sorts of functionality to it. And this is really where R shines because there's so many things that you can do. And it all really depends on someone actually writing, the code to make that happen. So these are not all of the packages that are available, but these are pretty common ones. And we'll talk a little bit about, the one that we're going to load next is one called dplyr, which is this one, because there's this whole thing called the tidyverse, which is a whole language that brings stuff together and makes really pretty plots. So we are going to play with that today. Not everyone uses this, but it's all right. ggplot2 is a fantastic one for plotting too. With any luck, I'll be able to show you some of that today. Yeah, that's because I got a lot of these installed because I do a lot of stuff. So I'm going to show you how to install packages now. And you'll find that sometimes you just, there's a thing that you need to do where you just install a package to do one particular thing. But yeah, these are all the different sort of packages that are here, but you're right, these are ones that are installed. So let's go and let's see what happens when you look for best R packages, right? Where do you find all of these packages? So, there's a whole bunch of lists, and this one comes from Posit, which is the people who make RStudio. And there's a bunch of different packages here that you can use. So there are different ways to load different types of data. Like if you've got SPSS data, different packages that can deal with it. There's different ways of manipulating data. We're going to use dplyr. Sometimes I use a bit of tidyr as well. Stringr I use. Visualizing data, so it all depends on what you want to do. Modeling, so like actual statistical analyses. There's all these different packages, and I'm going to show you a handful of them today. Sorry, I realized I'm probably not actually sharing that bit of the screen. God damn it. Normally I share my whole screen, and then just in that one moment I wasn't. Okay, so quick list of useful R packages. If you search for best R packages, gives you this page. And so what I was saying is, here's a whole bunch of packages that you can use to load data. Here's ones to manipulate data. So this is things like, creating new variables. I'll show you a little bit of this today. Lubridate is a really good one for time data and date data. So that's a very helpful one. Ways to plot data. So I use ggplot2 quite a lot, but I use a whole bunch of different things here too. It just really depends on what I need. Now, how the hell are you meant to know about all these packages and what's best for you? Because there's so many. You're not, basically. There are some that you'll see from time to time that are really good. But because there are so many packages here that are made by all these different types of people, it's really hard to keep up when new packages come out. You're not expected to. But this is where the R community becomes really good. So you can go, I'm trying to do this thing in R. How do I do it? And I can guarantee you there will be many other people across the world who have tried to do it too. So there are lots of R forums. Google is your friend here. And also GPT is really good at suggesting packages for this kind of thing too. So I do...
Recording stopped.
Oh my God, why is the recording stopped? Okay, the recording has stopped. Can you give me, let's pause for a moment while I contact Grace and get her to come back so I can keep recording, because this is going to annoy me. Okay, so I won't be a sec. I'm sorry. Now I should still be sharing here. Okay, so what we're going to do now is installing packages, and then we'll also do loading packages here as well, to show you how this works, and then playing around with one a little bit. So the package that we're going to want is this thing called dplyr. And at the moment, it is installed on mine, but it's not installed on yours. So to install a package, what you do is you type install packages, and then in inverted commas, dplyr. Okay, so double inverted commas there. All one word, no breaks, so that you wouldn't have breaks between a command and its brackets, for example. So install packages dplyr, and it has to be in inverted commas. And there's an important thing here as well, which is that if you type your code into Word, all right, and I put that over, see how dplyr isn't in green and I'm getting a red cross here? So there's actually like a little bit of code checking here too. So there's some, I like that there's code checking here. And when you hover over it, it says there's an unexpected token, which is the inverted commas. And that's because Word uses curly inverted commas, and R is like, I don't know what those things are. So when you type it in here, it's fine. But if you use Word as your code repository, you're going to run into this a lot. So you just have to remember you've got to change the inverted commas all the time, which is really quite annoying, but it's doable. And then it makes the little thing go away. Okay. Now, you will not want to install packages every time that you use, run your script. Okay. You just want to install packages as you need. Right. So this is the kind of thing where you can definitely have it in your script, but if you were sending your script to someone else, particularly someone who uses R a lot, you would probably comment this out so it doesn't go through the installation process every time. So installing it is different to loading it. And we're going to do loading in a second. You always have to load it in a script you're going to use it. But in terms of installing it, you only usually need to do this once, or if it needs to be updated.
Recording in progress. Got it?
Yeah, you might have to hang in here because I think it was because I'm not a person who can record.
Okay. I I will just put myself on mute and leave it rolling.
Thank you very much. I don't know
Cool.
where these are saving either.
Cool. All right.
All right, cool. Thank you. So just for the sake of the recording, I'll just go through that a little bit again. So we're going to install a package here. It's called dplyr, and it's the code for this is install.packages dplyr. And what I was saying was that if you type this out in Word and copy it across, it uses a different type of inverted commas. And I'll actually get like a little error thing there too. So these are like curly inverted commas. They don't look very different, but R is just like, I don't know what that is, and I won't run it. So if you do use Word as your repository here for all of your code, you're going to run into that quite a lot. Use something like a text editor instead. All right. So I'm going to install that, and you'll see it's going to, so I'll run that, and it will give me all this sort of like brown colored code here. It's installed something, and it says, fine, it's done. Most of the time, when you install packages here, you'll be installing things from like CRAN or whatever, and you can just use this default stuff. If you're getting super fancy down the track, you can call on packages that are not installed on places like CRAN and stuff, and you can specify where to get it to. Chances are you won't be doing that very often, but sometimes you might find a package where that's needed. All right, now that that's installed, I'm not going to need to run that again, so I'm going to comment that out. All right. However, what I do need to do now is to load it. And this is the library command. And notice that this one doesn't require the inverted commas around dplyr. I don't know why. There's all these little inconsistencies like this, but it's just how it works sometimes. All right, so library dplyr. And if am I still sharing my screen as well? Great. I just can't see the green around it now. All right, so if I run this, then it's saying, cool, I've loaded dplyr. So they've attached the package, that's what they call it. And what it's also done is done a thing here where it's masked some stuff. So usually when you do things like this, it will give you little notes. Now, this is because things like these are commands, things like filter and lag are already functions in R, right? But dplyr does it a bit of a different way. So what it's saying is that, cool, I know that there are these functions like filter and lag in stats, in R here. However, I want to do it a different way. So if you call on filter, which we're going to do in a sec, it's going to do it the dplyr way, not the base R way. All right. So that's just what that is. People kind of freak out when they see these things in brown because often the warning messages, like the error messages, are in brown, and so they're like, "Oh my god, what happened?" But this gives you little packet messages like this all the time. Okay, so now we've got dplyr loaded. What this means is that we can start to do a little bit more stuff with the data in a way that other people do. So what we're going to do is we'll do one here where we're going to create a new variable, and we're going to have a look at like a little bit of dplyr syntax here, okay? So I'm going to create new variable. All right, and what I'm going to do is I'm going to start by saying, all right, I'm going to get my mtcars data set and I'm going to shove something into it. All right, I'm saving something into my mtcars data set. And what I want saving into it is I want to do this thing called mutating, which is the recoding command. Feels a bit weird, like someone's like sci-fi and aliens and stuff like that, but that's what they went for. And the format that this is looking for, you see when I sort of hover over this, it's saying, all right, the first thing I want to see is what data are you using for this? So we've only got one data set opened here, mtcars, so it's the only one it can be, but we're specifying that here. Then the next thing I want to do, suggest is what I'm going to do. So it's HP per WT, which is HP over WT. All right. Now what this is, I'm creating a new variable called HP per WT with underscores there between them. And it's just given by the variables that we've got in there already. One of them is HP, and I'm dividing it by WT. So it's going to be like a weight-rated horsepower thing, which makes sense to car people. So that's what we're going to save. And there will now be another new variable in our data set here. All right. So let's do that. Let's run that. And you'll see that nothing really changes here in terms of my MT cars, except we're now up to 13 variables because we added that cylinder factor one. And now we've added this HP per weight thing. So let's go and have a look at the summary of my data set and just get a sense of what it looks like. And here's my HP per weight thing. It's treating it as continuous here. So I've got a new variable in there to play with. Cool. So there's loads of other types of things that you can do with the mutate command. Like you can recode things into, you know, a variable that has values above 20 and below 20, for example. You can recode that into a categorical variable. There's all sorts of things you can do with that. And I'm actually doing up a bit of a cheat sheet on this for you. Which will be part of the workbook. It's not quite finished because I wasn't sure where I was going to get up to today in this talk, but we can definitely, you know, I can give you a bit of a cheat sheet there. It's the kind of thing that's useful to hold on to. Let me show you a couple of other things that we can do here with dplyr, and also like you can do this in base R as well, but you'll see that the language is pretty handy here in terms of like it's fairly consistent throughout dplyr. That's kind of the idea. Let's say I want to make a version of this data set where I'm only going to look at cars that have a miles per gallon above 20. All right, so I want to do an analysis, say, on a subset of my data, not on all of the data. So what I'm going to do is I'm going to create a new data object, right? A new data frame here, essentially, which is given by, I'm going to filter. There's that command that is now doing it in the dplyr way, right? It's expecting syntax or code that's in the dplyr language as opposed to the base R language. All right, and I'm going to take the MT cars data set and I'm only going to allow them if miles per gallon is above 20. All right, so this is going to create another object over here in the environment. It's going to leave this MT cars one as it was, but it's creating a new version of the data, which I could use for another analysis here. And only the cars that are miles per gallon greater than 20. So, you know, this is the kind of thing where you might want to do an analysis specifically on a subset of your data. This is how you can do it and just use that as your data going forward. So I'll run that, and here's my MT cars filtered, and now there aren't 32 observations. There are only 14 observations. Notice it's pulled over all of the variables, but it's only grabbed the observations that had miles per gallon greater than 20. All right, so it's a way of subsetting your data if you need to. Is that all right? Cool. Ways of selecting observations. Now, the other thing is, I'm sure we're all really used to having data sets which are ridiculously huge and have hundreds of variables in them. And it's often really hard to find the ones that you want. So another thing you can do here is rather than selecting the rows based on having miles per gallon greater than 20, you can actually choose just the columns you want. So you can make a little sub data set of only the particular columns that you've selected. So MT cars underscore selected is given by select MT cars as the data set, and I only want these variables, miles per gallon and HP, horsepower, okay? And everything else will still be there in my MT cars data set, so I can still call back to that if I want to. But I only want to do, for this data set, I'm just doing an analysis focused just on miles per gallon and horsepower. So with that in mind, I'm going to create this new one called MT cars selected. I will run it. And now I've got all 32 observations still, but only on those two variables, you know, and I can click on that. And all I will see is miles per gallon and horsepower here for the different cars. Cool. So really handy, super easy ways of selecting the data that you want. Compare that to something like SPSS, where you've got to go through data, select cases, and all these sorts of things. You can just create a new version of your data, use that for a few analyses, and then go back to the full data set for the rest of your analyses there if you would like. All right. So any questions there around playing with data, Chris? Oh, you just click on the right here. Yeah. So you can click on these things and it will show you the different versions of the data here. Yeah. So, this display of the data is okay when you've got not a lot of data. But when you've got, say, like a Qualtrics survey file with like hundreds of variables in there and things, this is like a difficult way to get a sense of what's in your data. And that is one of the bigger complaints about R is dealing with really big data sets and finding which variables you've got in there. It can be pretty tricky. Okay. Cool. So we've done a bit here now. And the next thing I'm going to do is show you some analyses and pulling data out of R, and then a little bit on some best practices here to help you be a little more like, I don't know, organized in what you're doing. And we'll talk about pros and cons of R. So that's what I'm going to play around with a bit today. If I have a chance, I'll show you some of the things that I've been able to do here as well, depending on time. So I think now's a good time for just take, I don't know, 5 minutes. We'll come back at 5 past, and get back into it. So, go get some coffee, chocolate, whatever it takes to get you through with stats. I know. But I'm just trying to get you, like, for the start here, just into how the commands work and the types of things you can do. And now we're going to get into some actual stats. See you in a bit. All right, so we've just been, and we're still recording, we are, and I'm sharing, I am. Cool. So we've just been talking about starting to sort of manipulate variables and things too. I'm just sort of, I guess, highlighting in higher level details the types of things that you can do. And we'll get into the specifics a little bit as we go. Now I want to talk about like exploring our variables a little bit, including some very basic plots. I'm going to show you some nicer plots a bit later. But again, just to sort of show you some of the function. We'll get into some of the basic types of tests, like t-tests and ANOVAs and those sorts of things. And then I'm going to show you an example of where R really starts to come together, which is functions. Because I'm going to show you why some of the built-in stuff, like correlations and stuff, is the example I'm going to use, is a little bit underwhelming and the kind of thing we can do to make it much more useful for us. Show you basic regression as well. And so let's go through that. All right, so we're going to start off with, let's go with this MPG thing. Let's do a continuous variable. All right, and from this summary here, I've already got things like my mean and stuff like that, but I don't have things like my standard deviation. So how do I go and get this? Let's play around a little bit. And give you a sense of some more commands that we can do. So I'm going to do a thing called mean MPG, and I'm going to do that arrow into it, and it's going to be the mean of MT cars dollars MPG. All right. So again, the structure here is I'm creating a thing. Now, up until now, these things like MT cars and the filtered version and the selected version have been data sets. But what I want to show you here is we can make anything, even a mean of a variable, into a thing, into something that we can put into our environment and that we can call later. So I'm going to run that, and notice it doesn't give me any output. It doesn't tell me what the mean is, but it creates a value up here, a thing in our environment that I can call on. And that means that I can now use that in anything else I need. Like if I need to create a table with that in there, or if I need to use that in a calculation, for example, I can. What about SD? So as you're probably going to guess, it's SDs, which is standard deviation. So I'll do the same thing, which is SD MT cars dollar MPG. Okay. So we're just creating a thing called SD of MPG, and there it is, 6.03. So I've got that there if I need it. Okay, cool. What we can do, and I'm going to show you a little bit more of like actually getting the data out, is there are all these cool packages for getting descriptives out of my data sets and actually making them into nicely formatted kind of tables. So I'm going to come to that in a second, but I also want to show you the idea of doing a histogram. So we're used to having a look at histograms. So histogram is just hist, mtcars $mpg. So I want you to run that. And this is the first time we've had a figure over here. So this is where our figures come out. And these, the size of these and the dimensions of these depends on how you've got this window set up. So you can adjust this window around and it'll change all the, display on it. Now, I probably wouldn't put this into a like thesis, for example, because things like the title and the X label axis are not great. So we can actually change these, and this is where we can have function like arguments in commands. So I can do the main, which is the main title, is histogram of MPG, right, in inverted commas. So I'm taking that histogram command that I've just done, which is mtcars $mpg, and I'm adding in this thing, which is main, and then histogram of MPG. If I run that, what you'll see is this doesn't say histogram of mtcars $mpg anymore. Instead, it's changed into something that's a bit better. All right. And I can do the same with things like the X label equals miles per gallon rather than mtcars $mpg. All right, that's looking better. Supervisor's probably not going to kill me this time. So that's all right. What about if I want to, I don't know, make it a different color? There are all these built-in colors. And notice here when I've sort of typed out the words like light blue, it's actually showing it in light blue. So that will give you a sense of whether the colors are going to work okay. And I'll show you where we can find all the colors and stuff in a second. There's lots more that we can do with this. All right. So where do I find help on how do I know what all these arguments are? So if I go here and I want to find like the hist command, here we go, histogram X, which is the variable you want to do it for. And then here's all the things that you can adjust. So you can adjust things like breaks, like how big the breaks are between the columns and things like that. There's all sorts of things that you can adjust in this to make it how you want it to. You can, limit where the axes start and stop, for example. You can say how many different bars you want in the histogram. And you can specify all this in code. And that means that you can make, like, let's say you're doing histograms for a bunch of different variables. You can make them as consistent or as different as you want because they can all be specified in the code that you use to pull it up. And again, contrast this to something like SPSS, where when you run a figure, you got to double click into it and then adjust it how you want and save it and all that. All right, so help is like a handy place to find all of these things that you can play around with. And here's all the arguments that you can choose, and it talks you through them. It's not exactly plain language. It's a bit annoying like that. But again, this is the kind of thing where GPT can be really good. So let's do a GPT call to see something here, for example. All right, so in R, I have a histogram using the hist command. I want to make it, I don't know, red and change the number of bars to 7, for example. GPT is quite good at this. It will come out with, here's the code, like here's the histogram thing. And see how we need to change breaks to 7, change the color to red, all sorts of things here that you can adjust. So let's try that. Let's add this breaks command in. All right. And this is a nice example of like my code for this line is getting a bit long. Let's break it over onto the next line. And then breaks equals 7. So at the moment, my plot, I can just click back to my plot, has 5 breaks. But if I make this into 7, it's not going to work for me. Of course it's not. it might not allow it because maybe there aren't that many. There we go. It won't let you do something stupid as well. So there might not have been enough to have 7 different breaks. But notice it didn't tell me. And this is where R can get really annoying because it's just kind of like, you shouldn't really do that. So I'm not going to let you. But anyway, but I could change it to 3, for example. So you can see that the code worked. All right. So arguments in commands are a really important part of R, and understanding what they are and also understanding what the defaults are of an argument. It's handy to have that code there for you. And the help menu is great for this. All right. What about a box plot? So I've got some code here ready to go for the box plot. So I'm going to pull this across. And as you probably guess, it's just box plot. Empty cars with the MPG variable again. I've got a box plot of MPG as my title. I've got my Y label this time being miles per gallon. And I'm going to do this in, I don't know, light green for some reason. And there's my box plot. Okay. So these are the bog standard R figures, and often they're pretty good. But I'm hoping to show you a bit of ggplot today to show you how things can get really cool. All right, what about categorical variables? So we have that cylinder count variable. So I'm going to try something here, which is table empty cars dollar sil underscore factor. All right, and this will give me a little table here of these are the number of cylinders and these are the number in each group. Now, that's not that useful, trying to get that sort of output out. So I'm going to show you some stuff around summarizing output in a sec here too. Okie dokie. What else can we do here? Let's do a bar plot of cylinders. So I'm just going to, I had a whole bunch of code here and I'm just going to copy it all in. Don't worry, you're not missing much. I'm just demonstrating something here. Here's like a bar plot of the different numbers of cylinders. This is a better visualization, but as you know, many of our things have, like rather than that little table that came out, but as you know, often we'll have many variables and we run into issues there around like having graphs for absolutely everything. So summary tables are usually better here. Sorry, comment in the chat. How to create box plot. All right, so box plot, sorry, it's just the command is box plot, box plot, and then the variable that you want, and then any modifiers or subcommands here that you want in there. Okay. All right. So any questions there about like just getting a feel for our data and everything? That's all okay so far? Yeah, there is, but I kind of prefer to get it out in a table, for example, like, and particularly in APA format too. And there is a package that's just slipping my mind at the moment, and I'm trying to think what it is, but it's really good for it. I'm going to take that one on notice because I want to have that to show you, and I might show you next time where I'm really going to focus more on actually using this for proper reporting. Yeah, if I had it in my head, I would show you now, but it's just driving me nuts. Christy Lee might know because I know she uses this a bit, but I also know she doesn't want to come on chat right now and talk right now, so that's fine. But I've got it there. I've got it in so many scripts. I just don't have it in my head. Sorry, I'm not as prepared as I would like to be today. All right, let's do some, so we've got some data wrangling there. Let's do some statistical analyses, okay? So let's get my fancy headings here, all right? And I'm gonna separate this out into statistical analyses, and I'm gonna show you how things come out and at first, and then I'm gonna show you how we can make it a little bit nicer, particularly with the correlation example. So what we're gonna do is we're gonna do a t-test, and I'm going to create an output thing here, like something in my environment that saves it rather than just running the t-test. Because I can just do t-test MPG by the factor of VS, for example, and data equals empty cars. So notice here, I'm actually using the factor sort of function within this call here. And why don't you like it? There's something it doesn't like. I think I fixed it now. Yep. So I hadn't set up VS as a factor. If you have a look back at my data, empty cars, VS is still continuous here. All right, but it's got two groups, 0 and 1. That's this column here. And I don't want to muck around at the moment with making it categorical, but it needs to be categorical for this analysis. So I can actually just do that within the analysis. Like I don't have to, go back and actually do that change straight away. So this is handy when you're kind of caught on the fly there a little bit. Or you don't want to set up your whole data set and just do the variables as you need them. So I'll run that and I get this t-test thing here, and this is what it looks like, and it's all a bit ugly. What I would probably prefer to do is actually to save this as a thing, and I'll show you why we want to do that in a second. All right, so I'm going to rerun that again, and it's going to save it as t-test results, and I'll show you why in a sec. So here I've got like my actual t value, which is minus 4.67. I've got my degrees of freedom, and the degrees of freedom have a decimal place because by default it's running a Welch t-test. That's what it does. If we want to, we can change it to a standard t-test. And I've got a p-value here, which is less than 0.001. Okay, so it's there, it's all there. I've got a 95% CI, and I've also got my means for each of my groups as well to facilitate easy kind of interpretation of my result. Okay. Now, the reason I like saving this into a data little frame here is because see this little blue arrow next to it? I can actually click on that and it shows me all of the things that are saved in there, like the actual t statistic, like the actual parameter, like the actual, which is degrees of freedom, like the actual p-value itself. And I can call on these if I would like to. So let's say I want t_test results dollar p.value. So this is like a little data set all by itself. And within that, these are the variables. And so I can type that in and run it. And this will show me the actual p-value there. So if I just want to pull up just one part of the output, that's really easy. And similarly, if I want to know my means for my groups, I can just pull that out of here too. All right, so handy little thing being able to pull out the individual bits of the output as you would like, which is just not really possible to do in SPSS. And you'll see, a bit more next week that this becomes really kind of useful where you want to isolate particular parts of a test or output, for example. Okay, an example being, and I'm going to show you part of this in a second with correlations, is where you want to show brain's gone. Number of significant stars, for example, for correlations. So I'm going to show you this in a sec. All right, so that's a t-test. Now let's have a look at our t-test help and see what our options are for this. So the command is just t.test. So I'll pop this in here. And there's a bunch of things we can do here. We can specify whether it's a one or a two-tailed test, for example. We can specify like a paired samples t-test if we need to, like related samples, yolk samples, those sorts of ones. We can specify, what confidence level we want to use. We might not always want to use 95%. And we can specify the formula there. And I'll talk more about the formula in a second there. But there's a bunch of different things that we can choose. All right. There is usually one in here about whether it's the normal t-test. I thought it was dependencies, but I'll leave that for now. What about an ANOVA? So let's do something that's got multiple levels here. Let's do cylinder had multiple levels. So this time I'm going to do ANOVA, which is AOV, analysis of variance. they don't call it ANOVA. They apparently it was too many letters. So it's called results. And we're going to, so just as we did with the t-test, we're going to shove the actual results into an item that I can have in my environment. So ANOVA results is AOV and it's MPEG by the tilde command. Why isn't this typing? Which is MPEG by that tilde command there, factor cylinder data equals MT cars. All right, now this formatting, I should have probably talked about this before. This formatting is DV by the tilde, any factors that are in there, any variables that are in our analysis. So when we're looking at doing things like regression later, we'll look at plotting, multiple things here, and we'll specify like plus between IVs. So that's what's coming. But for this ANOVA, we're only looking for one IV, and for t-test, we can only ever have one IV. So let's have a look at this one. We'll run it. It's not actually going to give me the output here, but it's going to give me the AOV results up here, which is up the top, because these are listed alphabetically over here to make them easy to find. And here are all the things it pulls out. So it's got all the sums of squares and all those kind of things in there too. So don't worry about that too much. Let's go and get like a nice little summary of our ANOVA. And to do this, we can just do summary AOV results. So we use summary quite a bit. This is one little thing that I find about RStudio is if you're on the very bottom line of your script and you start typing, sometimes it won't accept it. So that's just happened to me a couple of times. And I always forget. So I'm going to do a summary of my AOV results. And there's a table that looks kind of similar to what I've seen before in ANOVAs. Maybe a slightly different format. Maybe it's showing the degrees of freedom first before sums of squares. But here's my F value and here's my P value. And it's got an E in it, which indicates that it's very, very small. And it's also got significant stars here for me too. So 3 stars indicating that it's less than 0.001. All right. So once you've actually got the data set up how you want it, or even if you forgot to factor this, you can do it within the command, but actually running the analyses is pretty easy. So let me do another one. Let me do just a quick one. I wanted to do ANOVA results 2. Instead of this one being cylinder, I think I've got another one there, which is like gear or something. Yep, gear's got a few levels. All right, so let's have a look at what this one looks like. And that one's, sorry, it hasn't run because I need to ask for the summary. So it has actually run it and saved it, but here we go. Gear is associated with it too. And this is 2 degrees of freedom, so 3 levels. So not quite what I'm looking for yet. If I want to get into this a little bit more, I can do a cheeky test. So the way that I can do this is I can actually take this AOV results thing that I've already got and run a new command, which is cheeky HSD on AOV results. If I run that, then here I get my differences between 4 and 6 cylinders. It's the cylinders, yep. 4 and 8 cylinders and 6 and 8 cylinders. Confidence intervals, p-values for all of them. All right. So if I want to add more stuff, I just do the cheeky command there. And this is a great example of where we can do things like functions as well, where if I'm always going to do an ANOVA this way, I can create a little script for myself where it's like when I type this command, like AOV plus cheeky, whatever you want to call it, you're going to do an ANOVA and then you're going to do the cheeky HSD, so I don't have to do 2 steps all the time. And that's really what these functions are. If you find yourself doing the same kind of thing over and over again, you can set that up in R for yourself. And a lot of people do that and publish to their own packages just for them so that they can do it all the time. All right, so cool with statistical tests so far? Yeah. All right, let's do a correlation. So let's have a look at a correlation between, so we're going to call it correlation, and it's going to be a COR, C-O-R, MT cars, dollar, let's do MPG, and we're going to correlate that with MT cars HP. horsepower. Okay. So when I run this, it's going to run a correlation for me. And you notice it hasn't created like a whole data table up here for me. So all it's created for me is a value called correlation. And this is my actual R value here. So if I were to do a summary of correlation, this one has gives me like a 6-number summary here, means and medians and all that. And they're all exactly the same because the only value it's stored is my actual correlation coefficient. It hasn't even given me a p-value for it. That's a bit crap. So what about if we want to do something a little more complex than that? Now, I like this because this is the kind of thing where I'm going to use this over and over again, and I've asked GPT how to do it. So let me talk you through what I've done. I've gone to GPT and I've said, I want to run correlations, a correlation matrix between all the variables here, and I want you to give it to me as a table, please. So this is the code it gave me. You ready? Let's get rid of the other code to make it nice and clear. All right, but it'll give you the sense of the kind of thing that you can do, but you don't have to type this out every single time. Okay. So it's given me all of this. All right, from here onwards. So it's opening up some packages it's going to need, packages that I didn't even know that I needed. And let me see if I can actually drop this in the chat for you too. This will all be in the, there we go. Not as a direct message, as an everyone thing. All right. So this is all going to be in my booklet, and I actually have to split this up into 2, but this is a really nice example of how you can pull the bits out of the correlation results, for example, to make output that you want. All right, so there's the first bit of the code, and there's the second bit of the code. And I've dropped that in the chat there, so you can copy it across and try and play it if you want. But let me talk you through what it's doing. So the first thing it's going to do is make a correlation matrix between 4 variables here, and miles per gallon, horsepower, weight, and I don't know, whatever that one is. From these, it's going to pull out the R values, and it's also going to pull out P values. So instead of the core command, COR, we're using RCore, which is a better correlation command. And this one comes from a different package. Then with what we're also going to do is we're going to add significant stars depending on the p-values. So 1 star is p is less than 0.05, 2 stars if it's less than 0.01, and 3 stars if it's less than 0.001. Now, I can work out how to type all this out, but I don't want to. So I just got GPT to do it for me. Or you can find similar scripts online where other people have done this, and you can work it all out. So you don't need to know how to type this, which is often the biggest barrier to taking this up. Then it's going to put the correlations and the p-values together and put them into a table and print it along with the significant stars. So let's do this. And there's my correlations table. And it's even done it to 2 decimal places. And significant ones are indicated by stars. So looking good, I think. I'm quite happy with that. All right. Now, whole point here is seeing what we've done is we've done, like with the previous results, we've pulled out like little bits of output, for example, like the p-values or the actual correlation value. But here, what you can do is you can pull all those bits together, join them together into a table, and then print that table. All right. And again, you don't have to know how to do it because someone else did. All right. So any questions about correlations there? No. Just to highlight that there's this base functionality in here, but then a lot of people have worked out ways to do it a lot better. And that's the real trick to R, is finding the way that kind of works for you. And often it's a little bit of playing around to find that. All right, we're going to do one more, which is a linear model here, or a regression. And everyone in R loves regressions. So everything tends to be regression based. Christy Lee and Amanda Rebar will tell you all about this. So we're doing here an LM model. We're going to save it as LM model. And the command that we're going to use is LM. And the DV is miles per gallon. The IV is horsepower. And the data that we're using are MT cars. Okay, and then I want a summary of this model. And we're going to play around with this regression here to show you a little bit how regression is very easy to manipulate as we need. Okay, so here's my regression output. It gives me some residuals here to check if I would like to. It gives me my intercept, and it gives me my IV horsepower, predicting miles per gallon, 3 stars. So its p-value is less than 0.001, and this is a negative relationship. So when horsepower is higher, miles per gallon is lower, right? Is predicted to be lower. All right. Cool, easy regression. What if I want to take into account, I want to control for a second variable, and I want this variable to also include or to control for number of cylinders, and I'm going to do the factor version of cylinders because I want to see how this deals with a categorical variable. So I'm going to call this LM model 2. All right. And so the IV here is horsepower along with the factor version of cylinder, and we're predicting miles per gallon. So let's see what this one does. Oh yeah, because I reloaded the data. So here's one. I haven't done because up here somewhere I reloaded the data here as part of this. It doesn't have that cylinder factor in it anymore. So you need to be careful with that kind of thing sometimes. So I can just rerun that. I go and find where I did that cylinder factor thing. And even better is I might make a copy of this and bring it down here just before I need it. There we go. Or I could do factor sil in here as well. So here we go. I rerun it. And notice it's split out cylinder factor into 2 separate predictors. And each of these is dummy coded against 4 cylinders. So normally if I was doing this in SPSS, I would have to do the dummy coding myself with my variables before I run it. And that would drive me nuts. So instead, what works well here is that it does it for me. It knows it's a categorical variable. It knows there are 3 levels, so there need to be 2 dummy coded variables. And this one's called cylinder factor 6, which is comparing 6 cylinders versus 4 cylinders. And this one is sil factor 8, which is comparing 8 cylinders versus 4 cylinders. So it's split it up into a dummy coded variable for me against 4 cylinders, which is great. It saves me having to do all the coding myself. It assumes that that's the one you want as the reference. And if not, you might just have to change your data to sort of sort it out how you want it to. But cool, so it's controlling for that, and I can see when I can control for number of cylinders, the relationship between horsepower and weight is no longer statistically significant. All right, what about if I wanted to do an interaction? Well, here I can just replace the plus with an asterisk. All right, and let's see what happens this time. I might not do the cylinder one here. I might do another. I might do weight. I might do 2 continuous ones just to make it a little bit easier to see. All right, so when I do this, my model is miles per gallon predicted by HP and weight and their interaction here. And so it does all of these for me. It creates all of these terms, and it's a super simple bit of code to do it. I just change a plus to an asterisk. And you can play around with this all you want. Like you can change things into like models where you have some interactions and some not interacting with each other. All this, you can control it, and it's just all done through the code. But the code here, I think, is very simple to play with. All right. Now, I want to show you one more thing, which I really quite like, and it's a package called Stargazer, and it highlights a really important issue with packages in R. Okay, so I'm going to do a thing here called like load the package called Stargazer. And what I want to do is I want to create, so Stargazer is a tool, and I'll drop this into the chat here too, and I'll drop all of this into the chat so you can run it. Stargazer is a tool for giving you nice output. So let's see what this does, and I should specify file equals testing dot txt. Actually, I want to say this is HTML. So this is going to output an HTML file for me. And what I'm hoping to show you out of this is that this will first up not work because there's a problem with the package. And this highlights an important discussion point. I don't think it will work. And then I'll show you how to fix it. And then I'll show you the output because it's a really nice way of getting output out. So when I run this, it has run it, which is good. Sometimes Stargazer is not very long with long variable names, like long model names here. I've found that it breaks with anything more than 2 letters, but it's like M, so I have to rename these to M1 or M2, but it seems to work with LM model and LM model 2, which surprised me. So that's all right, that's working. And so what I want to show you is what it's actually printed out for me and how easy this would be to put into a document. So let me just find it. So this is output into my testing. Where does it put it? Where are my files? All right. So it is breaking. Let me try. So I'll rename these to M1 and M2. I'll change this. M2. And the reason I'm showing you all this is because this is the kind of thing that can go wrong with packages, and unfortunately happens quite a bit. And it might be because these are in single inverted commas. It can be a bit testy. And I won't spend too long on this. If I can't get it working, then that's okay. I will fix it in the booklet. So they're in the chat for you. Let's try this again. Create 2 new models. And what I was hoping it to do is to save a file for me here called testing.html, which I can open. It's not going to let me do it, but I can show you some other output that has been done this way so that you can get a sense of what it looks like. This can create very good looking tables that I've found are really useful for things like publications because they usually contain everything you need. Online survey. There we go. There you are. All right. So here's an example of a table which is predicting this variable by these things, gender, for example, individually. And you might want to modify this if you want. And there's like a multivariate analysis on the side here, for example. So this is printing out the actual regression coefficient, whether it's significant or not, and also its confidence interval. And each of these are models at the top. So tables like this can look okay. There's a bit of empty space in this one. So I modified them over into a single column. Let me see if there's another one that I can show you, which is quite nice. What about convergence? Here we go. This is one predicting a bunch of different DVs based on a bunch of different IVs here. It also includes the constant. It included things like the number of people who took part and model fit statistics like log likelihood or AIC and stuff there too. So it's the kind of thing where when you show this to a reviewer, they sit there and just go, okay, this person knows what an AIC is. I'm not going to argue anymore, but it does it all automatically for you. So this is, I think, one of the big things about R that people get a bit caught up on is actually getting the stuff out of R. It can be really tricky. But tools like this are good. And I want to find that demographics one for you as well, because I've used it and I just don't have it in my head. All right. So a big point here around packages is there are tons of them, but they do tend to break because R is constantly being updated. And over time, commands are no longer available or change how they work, and packages stop working unless someone's there updating them. And everyone moves on after a while. Sometimes there are groups of people moving on packages. Sometimes there are just individuals who are doing it, and they're not there anymore, or they're not in a university role anymore, or something like that. So, or they just don't care, because all of this is free, right? And the only, benefit that you're going to get out of making these packages is it might look good on like a promotion application, for example. But there comes a point where it's like, yeah, this isn't there for me anymore. Yeah, you might get some funding to do it too. So we like R packages, but they do break over time. I'd like to talk a little bit now about like a good workflow and how I do things and why I do it this way. So one thing that I do is, and I'll pop the code into the chat here. All right. So this is my first syntax file that I tend to do. So I'll go to File, New File, and Script, and I'll pop that in there. And what I'm doing, let me talk you through it. And I will save this and I'll call it one, opening data. All right. So this is my first syntax file. And the first little bit here, this little bit of code, rm list equals ls, what this will do when I run this is it will clear the environment. So if I've been working on like different syntax files and everything, and I just want to start from scratch when I'm running this script, I run this rm list equals ls open bracket, close bracket, close bracket. It's the most non-intuitive bit of, it's not smoke detectors. It's the most non-intuitive bit of code, but it's a really important one. So I have this like at the top of every script. And when I run this, this will clear out everything that I've done here. So I'm starting with a clean slate. And I try and do this at the start of every bit of every script that I do so that I know I'm starting with a clean slate. Then what I'm going to do is I'm going to load the packages I want. I'm going to load the mtcars data set, and I'm going to do this with mtcars. You'll note that the syntax that I popped in was reading off a data set called mtcars.csv, which you don't have. So I'll just do that little bit of code, but that would be how you would import a CSV file, for example. And then what I'm doing is I'm saving this into a data set called like an RData object. Here we go. And it saved this thing here called RData. Should have. All right. And there it is, mtcars data underscore RData. Now, if I'm loading in like multiple files, for example, I can save a bunch of different data sets all in the one same RData object. So for me, often I'm dealing with a multiple like different files and things. So this is all just loading them up, making sure that works, saving it in an RData format before I do anything else. Okay, I'm going to open up a new, and I'll just save that because that was glowing red at me. I will do File, New File, and Script. And this one here is going to be my second script. This is where I'm going to modify my data. Okay, so again, I start it with the RM list thing. And then what I'm going to do is I'm going to load that data set. I'm going to make some change, and then I'm going to save it into a new data set. Okay, so I load a new data set here. Let me just pop all of this into the chat for you. So I load that data set that I created in that first one. And just quickly before I forget, I will save this. This is called modifying data. Should be a dash, not an equals. All right, so I load in that data set that I did in the first script. All right, and if I need to make any changes in my first script, I just go back and run that again. And then I'm ready with whatever changes I've made to that data object. All right, I'll do that thing where I set up cylinders as a factor, and I will save this now as a cleaned data set. So this is also the kind of thing where you can do all of your recoding, all of your scale scoring, anything like that before you do your analyses, and save it into a new version of the data set that's ready to go for analysis. Cool. All right. So I can run that. Remember the first little bit, clear it all out. I've got some stuff that's still in my environment from that first script. And sure, I'm just reloading what I've done there anyway. But I don't want there to be conflicted copies. So the first thing, always clear everything out, load the thing that you want, do what you need to do, save it again as a new data object. All right. And then when I do that, here is my the new data object. Ooh, it doesn't like atomic vectors. Change this to as vector. And I'll just get rid of the levels. See if this one works for me. What the hell is an atomic vector? All right. So there's something quirky that's going on here. And this is one of those like not helpful R messages. And this is why, if I was teaching honors psychology students and these kind of things are popping up, they'd just be like, okay, I hate this. I hate statistics. I want it to go away. So this will be something that I'm going to have to play around with. Go, Chris. Yeah. Well, this should be loading MT cars into this. See, it's saving it only as the word MT cars. So there's something that's gone wrong with the loading here. Yeah. So I'll play around with this code and I'll update it for you. It's partly because I'm using like a built-in data set here, as opposed to if I do that. That's working better. And there it is. That's working now. So I just didn't like the way that I was. So here we go. Here's the updated code. Didn't like the way I was loading that into an object because it's fickle. It's just painful. But when you get it working, like this is the thing about art, you will, bash your head into a brick wall sometimes trying to work out why it's done a thing a certain way. But when you work it out and you fix it, it's like the best thing in the world. And sometimes it's worth the payoff. Yeah, GPT is pretty good at it. I do find that Claude is better for code. Claude is a better AI for code. So I've been trying to get GPT to fix like this really quite complex graph I'm working on, and it hasn't done it very well. But I took it to Claude, and Claude was like, "Yeah, I see it," and fixed it straight away. All right, and then my third syntax script. I'll start with that rm list equals list thing, and this is where I do my analyses. So I load in that clean version of the data. I'll do some correlations, and then we'll try a stargazer there as well. And I'll just save this as 3 is analysis. So I always know which order I need to run my scripts in. It's always opening data, then modifying data, and then doing the analyses. So having those numbers at the start kind of helps. We'll run this. And there you go. Look, it's given me that nice sort of looking table there for the correlation here. Although expressing it as a code. Oh, this is a regression. So yeah, Stargazer gave me that. Before I was trying to save it as like an actual HTML file, and that wasn't working. But this is Stargazer made it nice like this. And sometimes copying and pasting can be a little tricky. I still prefer it when it's an output file, but that's what Stargazer is being a bit painful about at the moment. All right. So that's the majority of today. What I might do is just give you like a little bit of a taste of some of the things I might show you next week as well. So if I go to, there are some things that I've been playing around with here. Let's do this one. So notice I'm trying to switch projects and it's going, do you want to save your R project here that you're just clicking out of? Always go yes. And this is going to take me over to this other thing that I've been playing around with. And this is what's called an R shiny object. So there's a bunch of code here. And this is going to create a visual for me, which is based on a thing called the gambling statistics. So the Queensland Government Statisticians Office puts out gambling statistics, all sorts of different things. So these are casino games, for example, and all the lines are different states. So I'm comparing states here, or I could compare across products if I like. So this is across Australia. Like most of the money here is gaming machines, which is pokies. For example, things like sports betting and stuff are still down here. That's on turnover. What if I change it to like real expenditure, which takes into account inflation? This is what this looks like. What about if we look at, I don't know, let's do Queensland. You know, lots here are wagering in Queensland. And then here's gaming machines here. So wagering is a bit of a bigger thing in Queen. It seems to be gaming. Sorry, gaming is, that makes sense. Gaming is pokies and casino table games. Wagering's here, so still picking up a bit. So I can do these kinds of interactive kind of objects. And I showed this to a funding body the other day, and they just went, "Holy crap, this is a game changer for us." Absolutely loved it. Let me show you another one that we're doing. Just to give you a sense of who the funder is. We can mock up some data here, which are from a previous prevalence study, not one that we did, but here is total gambling participation in the ACT in 2019. 60% of people in the ACT gambled. What about if we want to compare it by gender? Men doing a lot more. Surprise, surprise. We do dumb stuff. Here's age, for example. So, you know, sort of older people, they're doing a bit more, but, you know, this is overall gambling participation. This is often, you know, things like lotteries and stuff, which aren't too problematic. What about based on education? Here we go. Postgrads, least likely to gamble. I suppose we learned something, right? So these are all the types of things that we can do, and we can actually host that on websites, for example, and make them more visual. So this is all being done through a thing called ggplot2, which is related to dplyr. It's part of the thing called the tidyverse. And you can also do mapping data as well. Is this something that works? Let's see if this one, I'm not sure if this one works. I've got a different one. Yep. That doesn't have the shape file. Let's do this one. Graph of ACT by region. So what you can actually do is you can download like coordinates, which are called shape files, and actually print out these nice maps of like a state. For example, this is by electorate, and this is how many people gamble. This is all made up data. You know, but to give you a sense of where the hotspot of gambling might be. And what about if we change this to problems? There's more problems over here. What about if we wanted to use longitudinal and latitudinal data to map where all the pokies are? This is real data. Bigger means a venue that has more pokies, and you can hover over them and see how many there are. You can zoom in, zoom out. Blue is hotels, for example. But this is all of the stuff you can do in R once you get past those first issues of, oh my God, what the hell is this thing? All right. So I'm not going to be able to necessarily show you all of this next week. But the idea is to show you a bit more about things like plotting, particularly with ggplot and some of the cool figures that we can do, some of the more advanced data manipulations we can do, some more advanced modeling, and in particular, getting the output out. I want to spend a little more time on that because I'm not sure that came across very well today. So with that in mind, we're just about on time, but we've got some time for some questions. So please feel free to fire away. Yeah. It's exactly what it is. Yeah, it's a little app. Yeah. And this is all the stuff you can do like with R. Like there's so much that's like available. So one thing that I often do as well is I scrape Twitter, which is dying. So it's probably not the best, but it was good a couple of years ago. So, you know, like actually using a code to save all of the tweets that I want and then analyze them, for example. So there's all this stuff that you can do, like, you know, when you find data around, you've just got to know that it's possible to do it. Yeah, the thing about R compared to any other program is that it's so modifiable. You know, there's so much that we can do here. And like I said, just got to see what it is. So I like it. It still does my head in when you get these error messages and you're like, I don't know what this is. But when you get it working, it's fantastic. The other thing I'll try and do a little more of next week is Markdown 2, which is where you can actually call on analyses in a document and actually make that, how you're writing your paper. So that the data are in there, like the output is drawn into your document. I said you could pull out T values and P values. Well, why don't we actually embed that into a document, and make all the reporting automatic so you're not worried about typos and things like that too. So this is getting a bit more into the power of R, which is what we're going to play with next week. Cool. I think we're all right, aren't we? Chris, what's your takeaway? Because you're the one who's talking, so I'm picking on you. Yeah, yeah, yeah. Let me see if demo still works. There is, sorry, there's demos that you can do here too, where you can play around with graphics. Yeah, demo graphics. Sorry, you were saying? Yes, yes. All right. So this should be making plots for me. There we go. So here's like, using color in a plot. Here's color wheels and things like that. And you can, there's a lot of really good packages as well for things like one that I try and use a lot is packages for colorblind people, like which chooses colorblind friendly color palettes, which I really appreciate. Like I'm not colorblind, but I just think it's the right thing to do. So there's that kind of thing. Pie, I never use pie charts, but you get the idea. Um, Box plots, notched box plots, um, distances between Brownian motions, which sounds like just going to the toilet, to be honest. But anyway, level of interest in R over time, within a year, for example. Um, you know, Scatter plots. We saw a little bit like this is we saw a little bit last week in Jamovi, for example, the correlation plot where we had something similar to this. So, this, like I said, it's built on R, so it can call on all this stuff that R can do. Same kind of thing, but different colors by group. So this is different cylinders, I think. Oh no, that was Iris. Topographical maps. If you've got the spatial data, like I do with the ACT, all sorts of bits and pieces here, different ways of cutting data and combining figures there too. So there's, yeah, lots of different things that you can do. And there's some really pretty ones that I quite like too, where when you do them, everyone's like, ooh, he's doing it in R. He must know what he's doing. But yeah, lots of demos here. So you can do demo and just play around with a few of these too, to have a play. But I think that might do it for this week. So hopefully it's like got you a little bit interested in it. And, like I said, a bit of a steep learning curve at first. And like Christy Lee said in the chat there, it's awesome how much you can do. You just got to know that it's there. And there are a lot of communities around that sort of highlight different things there too. So I'll try and highlight those a little more next time too. For now, let's go and have a coffee. Thank you, everybody. See you next week.